Hello everyone. So today we are going to continue the sets part 2. In this video we will discuss the topic types of sets, subset, interval as subset of real number and universal set. Right? So before that actually we have completed the definitions of the sets and also the representation of the sets in the sets part 1 video. Right? So the first topic for the today is types of set, that is first one is empty set. So what will be the meaning of the empty set? First of all, can you tell me what is the meaning of empty word? So empty, it is nothing, void, right, or null. So means the set which does not consist of any element, that is called as the empty set, or another meaning of the empty is void set or null set, right? So the set which does not consist of any element, that is empty, that is only called as the empty set, right? So first of all, we will write the another name of this empty set. Another name of the empty sets is, we can say it is null set, null. Or what is the another name? Null set or void set, void set. So definitions of this will be how we will define this. The set which does not consist of any element, any element. Now I will take the example so that you will get the clarity on that. Any element is called as the empty set. How actually we are representing it? So it is denoted by, there are two symbols to represent it. It is denoted by, this is called as the phi. So either phi, or we can denote it by symbol of this set, this empty set. So either we can represent by this or we can represent it by this. Let us suppose here I am saying, tell me a natural number, tell me a natural number, let us suppose x, x is a natural number between 2 and 3. Can you tell me any natural number between 2 and 3? That should be lesser than, actually greater than x. X should be greater than 2 and lesser than 3. So what will be that natural number? Here, just one second, I will erase this part. Here you have to tell a natural number which is between 2 and 3. So what is that number? Can you please try to answer that? So here you will say there is no such number which lies between 2 and 3, and that is natural number, right? That means what we can say here, actually we can write it as set of x. We have a set, that is set of x, such that x belongs to natural number and x is between 2 and 3. So if it is a empty set, so we can represent here this thing with the symbol phi. Or also we can say it is empty set, means here nothing is there. Empty means it is nothing. Another example, can you tell me any student, those who is studying in both the class, 11th class as well as 12th class same time? Right? That means again there is no such student who can study in both the class same time in a school, right? So that type of the set is called as the empty set, where the elements are not possible in that set, right? Now singleton set, again the definitions of the singleton set is hidden in their word only. What is the singleton? Single means, what is the single means? The set which consists of only one element, or exactly one element. So the set which consists of how many elements? So consists of only one element. Only one element is called as what? Element is called as the singleton set. There is no specific notation for the singleton set. General notation for the symbol what we are using here, we are going to use for that. So example, with the example now we'll see what will be the example for that. Can you tell me a prime number, even prime number? Here, x such that set of x such that x is an even prime number. So what will be the answer? Even prime number. What will be the answer for these questions? For this set actually, if you write in the roster form, so that is 2. That means it consists of only one element. So any such type of the set which consists of only one element, that is single element, that is called as the singleton set. By the word single, you can define the meaning, right? Means which consists of only one. Only one means single. Here, single only one. Empty was nothing was there, right? So the two types is done. Now we'll move to the next type. That is the finite set and infinite set. What will be the finite meaning? Means here again the finite means what? The set which consists of countable number of elements. If you count the number of elements present in any set, then it will be called as the finite set, right? Let us suppose here you have a set V that consists of all the vowels, that consists of all the vowels A, E, I, O, U. So definitely we can count there are 5 elements in this set. So definite number of elements are there, or we can say that countable number of elements are there. So this is called as the finite set. Here we can take this set also, this empty set. This empty set also will come under the finite set only. Means we can say there is no element, right? That means we can decide it has elements or not. If it has, how many are there, that also we can decide. So empty set, so the empty set or the definite number of elements present in any set, then that is called as the finite set. So the set which consists of the set which consists of countable number of elements, number of elements, right? Elements, that is called as the vowel, that is called as the finite set. This is also called as the finite set. We can take multiple examples, right? Here for this finite set, right? For infinite set, the set which is not finite, that will be the infinite set, right? So here you can write the definitions by yourself. It is very simple. Let us suppose I am saying, tell me the set of natural number. Set of natural number. Can you count the set of all number which is natural number? Like here you have to write like this: 1, and then 2, then 3, and then it will follow a pattern. So pattern we are writing by dot dot. 3 dot actually we are using when it is uncountable. When the number of elements are uncountable, then we are writing the dot 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 to represent that it follows the same pattern. 1, 2, 3, 4, 5, 6, up to infinity it will go, right? So you cannot say that, sir, we know that there are infinite number of elements. No, infinite means we don't know actually. It is a definitely large number, very large number, right? So we cannot say exactly what is the definite that infinity values. So whenever we have such type of the number, then it is called as a indefinite set. Means the set are uncountable. Then it is called as the indefinite set. Or yeah, infinite set. Infinite set, not indefinite. Sorry. So now next one is the equal set. What will be the equal set? Again, equal means what? If two sets are exactly same, means elements present in the two sets are exactly same, then the sets are called as the equal sets. Means here we are discussing about the two sets. Two sets should be given, then only we can say whether these are equal or not. So two sets A and B, two sets, and both the sets should be actually finite set. That also you can write. Two sets A and B are said to be equal set when said to be equal set if the number, if the elements are exactly same, are exactly same. Let us suppose here I am writing set A consists of element. This is the example. Set A consists of 3 elements. Let us suppose I am writing randomly 1, 2, 3 elements. So what will be the second set? So another B set, that also should consist of the same element, but order may be different. Means we can write as 2, 1, comma 3 because order in this set doesn't matter. So we can write as 1 comma 2 comma 3 or so 1 comma 2 comma 3 as it is. So order doesn't matter. How we are representing equal set? So very simple. A is equal to B. That means we can say this set A is equal to B. This equal to symbol only we are using. So any two set which consist of exactly same element, then that set are called as equal set. Now equivalent set. What is the equivalent? Now actually whenever we are saying the equal set, that means they have same element as well as same number of element. Or actually in the finite set, when we are saying finite set here in the last slide, we said finite set, that means we can count the number of elements. So number of element is only called as the equivalent set. Means what is equivalent set? So equivalent set are nothing but two set A and B. Sorry, two set, no, it is two set here. You have to write two set A and B are called as equivalent if it consists of same number of elements. Two sets A and B are said to be equivalent when, so if it consists of same number of elements. Here number of element matters. Same number of elements. Let us suppose here we have a set A which consists of 1 comma 2 comma 5. That means how many elements are there? So to write the number of element, we can write like this. Number of element in set A, n of A is equal to how many? So there are 3 elements. So we are writing like this. If we have the set B which consists of, let us suppose this consists of the A, B, C. So here actually you can see what elements are present, that doesn't matter. Like here in the first set A, it is given 1, 5 means number are there. But in the set B, we have given the alphabet A, comma, B, comma, C. But it doesn't matter, just we need the number of elements. So here what is the number of element? Here again, if you see the number of element in the set B, we will write like NB again 3. That means if the number of element in the set two sets are same, then it is called as the equivalent set. So here A is equivalent to B. How we are representing it? So in mathematical with by the mathematical symbols, we are representing it by A is equivalent to B by this symbol. This is the symbol for equivalent. This is for equivalent. For equal to, we are using the equal to sign only, but for equivalent, this arrow, double arrow sign we are using, right? So this is equivalent. Now, what is the cardinal number of this set? These are the extra fact actually that this NCERT. Cardinal number is nothing but the number of elements present in any set. What is that? Number of elements. Number of elements present in any set. Elements present in any sets is called as the cardinal number. I am taking one set or previous set also we can take, but I am writing again. It consists of, let us suppose, A, comma, B, comma, C. So what is the cardinal number? Cardinal number means number of element present in this. Number of element present is equal to number of element present is 3. That means the cardinal number is 3. The cardinal number will be 3, right? So this is the types of the sets. What are the types of the sets? So we have already discussed, that is first one is the empty set. First one is the empty set, that means which does not consist of any element, completely empty, void, right? So the symbol here, important thing is how we are representing it. We are representing by the symbol either void or this curly bracket, open curly bracket. right? That is called as the empty set. Now singleton means the set which consists of just one element, that is called as the singleton set. Finite set means if the number of elements are countable, then it is called as the finite set. And actually it was finite set, and if the number of elements are uncountable, then it is called as the infinite set. Now here we have equivalent and cardinal number, equal set, that already we discussed. Now we will come to the subset. What is the subset? Here what subset you can understand, sub means what? It will be smaller than the given set. Subset means the set which is made from a given set, written by the help of the elements of the given set, that is only called as the subset or not. But here in the mathematical way we are defining, first I will take one example. Let us suppose here we have set A and B. I am writing first B. This consists of, let us suppose here we have 1, comma 2, comma 3, comma 4. We can take actually any element. Now we have the set A. This consists of only two elements. I am taking 2 and 3. Means we can see here, this here we can say A is the subset of, this is the symbol of the subset. A is the subset of B. So why actually we are saying that A is the subset of B? Now here we have to understand whatever elements which are present in the set A are also present in the set B. Or in other way, what we can say, this A is written by the element of the set B only, right? That means set A is the subset of B. Why? Because all the element of the set A are also the part of the set B, right? So this is the smaller set. This is the smaller set, but the elements are belongs to the set B only. So that's why it is called as the subset. How we can define it? So here the set A is called as the set A is called as the subset of B. Set A is said to be the subset of B. The set A is called as subset of B if all the elements of, since A we are saying A is the subset, so all the element of A is also the element of set B. Element of set B. The same example things I have written in the word only, right? So this B, A is called as the subset of B, and we are writing like this. In symbol form, how we are writing this thing? Symbolically, by symbol, we can write this like, symbolically we can write it as, if you are saying that A is the subset of B, this implies that what? This implies that if, let us suppose, A belongs to the set A, then A belongs to the set A is the subset of B, then A belongs to, then this implies actually here A is the subset of B, means here actually we should write like this. If actually here, it is this part. Here this implies will give here. So A is the subset of B. When we can say A is the subset of B, let us suppose this small a belongs to the capital A. This implies that a small a also belongs to the capital B, right? Then only A will be called as the subset of B, right? Then it is called as the subset of B. Now here one idea actually you will be getting in your mind, that how many subset we can write for any set. As you can see here, A is one of the subset, right? But we can take the like element one and then we can write the another subset. So there are different subset are possible, right? So let us suppose the same thing I'm going to write here. Let us suppose you have a set A which consists of just one element. Let it is just two. So what will be their subset? Here we are going to write the subset of this. So subsets. Subset first, empty set will be the subset of every set because the empty set also does not consist of anything. That means here any set consists of one empty set also, right? So empty set is actually the subset of every set that we have to keep in mind. And next subset that we can write with the help of the set A is that is the set itself, empty set and the set itself. Let us suppose we have given another set B that consists of two elements like 2 comma 3. Then what will be the subset of this B set? So the first will be the again the empty set, since empty set is the subset of every set. Now another one will be the 2, this will be the subset, or we can say next 3 will be the subset, or last one will be the what? Set itself, that means 2 comma 3 will be the subset, right? So these are the subset. One more we will say, take like C. If C consists of one, 2, 3, 3 elements, then how many subset are possible for this? So first you will say empty set, and then you will say the set which consists of element 1, the set which consists of element 2, the set which consists of element 3, the set which consists of element 1 comma 2, and then you will say the set which consists of element 1 comma 3, and the set which consists of 2 comma 3. That means you can just count how many elements we are getting here in each the cases. Now we will write here how many subset we are getting. Number of subset means we are just trying to find out this number of subset is dependent on which quantity. So here if you see carefully here, very clearly you can see that here when the number of elements in the set A is equal to 1, that time we are getting the 2 subset. When number of element is 1, that time we are getting 2 subset. When the number of elements in the set B is equal to 2, then here we are getting how many subset? 1, 2, 3, 4. Then we are getting four subsets. When the number of elements are 3, then we are getting here how many subset? 1, 2, 3, 4, 5, 6, 7. And then we have missed one subset. Actually, one more will come. What is that? Here we should mention one more subset, that is 1 comma 2, 1 comma 3, and 2 comma 3, and the set itself that is 1 comma 2 comma 3. That means here how many subset we are getting? So we are getting the total number of subset is equal to 8. The same thing we can write like this. 2 means 2 to the power 1. 4 we can write as 2 to the power, in the terms of the 2 we want to write. So 2 to the power 2, and this is nothing but 2 to the power 3. This power 1, power 2, power 3 is nothing but the number of element in the set A, right? So is the number of element in the set A. Let us suppose we are taking, let n be the number of element in any set, and be the number of element in any set, then can you tell me by this concept how many subset will be there for that set? So this number of subset will be the number of subset subset will be equal to 2 to the power n, right? Since the number of element is n, when the number of element was 1, then it is 2 to the power 1. When the number of element was 2, then it is 2 to the power 2. Then when number of elements are 3, then it is 2 to the power 3. So when the number of elements are n, then it will be 2 to the power n, right? So this is the concept of the subset. Here we are getting the how many subset? 2 to the power n. So this is one of the very, very important formula. Directly we are going to use it in the problem solving, right? So number of subset of any set is equal to 2 to the power n, and we can write the subset for any set, right? Now some points here, you can observe that the empty set is the subset of every set, and the set itself also is the subset of every set. These 2 points actually we should note down, right? Empty set is the subset of every set. What are the point? These 2 points. The first one is empty set is subset of every set of It is like friend of everyone, subset of every set, right? And second point is what? The set itself, the given set is the subset of itself. The set is the subset of itself. The given set is the subset of itself. The set is subset of itself. Now we have to understand two more points here. What are that? Let us suppose here we have two set and no points actually that points we have to note down. I'm saying A is the subset of B and also I'm saying that same time B is the subset of A. Is it possible that A is the subset of B and B is the subset of B? Yes, this will be possible only in one case. If and only if. This is the symbol for if and only if. Both side arrow. If and only if A is equal to B. Only if A is equal to B, then only we can say A and B are the subset. Both should be the same set or equal set, then only we can say A is the subset of B and B is the subset of A. Right? One more point here we have to note down. Proper subset. What is the proper subset? Proper subset. What is the word this proper means? Actually, when we are saying subset, so that subset should be smaller than the given set, then only it will be proper or not. Because sub word means smaller than the given set. But when it is not a small, then it is not a proper subset. As we know, the set, all the sets are the subset of itself, right? So that here for proper subset, actually, what is the conditions? Then we'll see the example. If you have the set A, which is the subset of B, when it will be proper subset? If A is not equal to B. If A is equal to B, then it cannot be the proper subset. Let us suppose here you have A is equal to 1 comma 2 and B consists of also 1 comma 2, then can we say it is a proper subset? No, because A is here equal to B. In that case, not, it is not a proper subset. So here we have to take any other element also. Now here you can see that A is not equal to B. So here we can say that A is the proper subset of B or B is called as the superset of A. A is called what? A is called as the proper subset of B and it is the proper subset of what? B. And B is called as the bigger one, right? So superset of A, right? So this 2 point proper subset and when A will be the subset of B and B will be the subset of A, it is possible only when the two sets are equal. In that case only it is possible, right? Now we have next point that is interval as the subset of real number. Like here as we discussed this subset. So subset means what? A smaller set. How many small set we can derive from the given set? Now let us suppose we have given a real number. Complete real number is only given. So how many set we can derive from the real number? Real number means what? It includes all type of the number except imaginary number, natural number, whole number, rational number, irrational number. So all type of the numbers will be included in the real number. That means here the real numbers subset will be infinite, right? Infinite subset we can derive. So how we are writing the subset of real number? So here first of all we are going to consider two number on the number line. I am going to consider two number on the number line. Here let us suppose we have let A and B. Sorry, this is just B. A and small b, A and B be the two real number, B the two real number and conditions A is greater than B and A is greater than B. Means here in the number line if you draw, this is a number line. Here we have given the A and then B. Why? Because why I'm writing A first? Because there are conditions we have taken. A is greater than B. Or actually, if I'm writing A like this, A should be lesser than B, right? Otherwise, we have to write here B first and then A. So, right, I will interchange that. Or actually, I will change the sign of that. Means here, this should be lesser than. A should be lesser than. Here we should give the sign lesser than. So A is lesser than B. That means we can represent on the number line like this. This is our plus infinity and this is minus infinity. This is the point A and this is the point B. Now here how we can write the subset of this real number. So the first point we are writing the subset in the form of what? So interval. Interval, how we are defining the interval. So now you have to understand. Here we have different type of the interval. Open interval. First one, open interval. What is called as the what is open interval? So interval. Open interval means let us suppose here we have a number line. This is our number line. Here from this point, let us suppose point A to point B. So many real number are there, right? But we want to take the subset from A to B for the real number. So subset in the case of the open interval means what? The A and B will be not included in that set. A and B will be not included. So except A and B, all the number between A and B will be the part of open interval. Means we are writing it as A comma B. We are writing it as A comma B. So this is called as the open interval. Means set of all real number x, or x belongs to what? X belongs to real number. So set of all real number where this real number is between what? Here how we can write it? What happened to this? Here we can write uh, x is greater than A but lesser than what? But lesser than B. Here you can see we have taken the symbol just greater and lesser. We are not taking equal to sign. Why? Because it is open interval. This means the point A and B is not included. Only the number which are between A and B are only the part of this open interval. So this is the subset of what? Real number. So this is one of the subset of the real number. Now, second one is closed interval. What will be the closed interval? Means in the same way we can define the closed interval. Here, the ending point also will be included in that subset or set. Means here if we have a number line like this is positive infinity and this is negative infinity. Let us suppose this is point A and this is point B. Now here this time we have to take the dark in dark circle. Dark circle, that means this point A and B is also included. How we are writing in interval forms? So interval form we are using the closed bracket. Closed bracket represent this point, and in this set symbol how we are writing? So here we will say x set of all x. What is x? X belongs to real number, and this x is from where to where? So x is greater than or equal to A but lesser than or equal to B, lesser than or equal to B, right? Now here universal set also, but so interval first, then we'll come to the universal set here. So close interval, and now we have two more type of this, that is semi-open and semi-close. So here only I will finish it. One is semi, third one semi-open or semi-closed means what? One side it will be included and one side it will be excluded. Means it will be like this. If you have a number line like this, so this is the point A, this is point B. So if this is not included and this is the dark circle, then here we are writing in interval form as here open bracket A and here we are writing close bracket, right? So now when we are writing another form of this only in third, here if you have the number line like A and this is B, how we are writing it? This side open, this side it will be closed. Means here we will take the close bracket A to B open bracket. So this is the semi-open and semi-closed. Semi-open and semi-closed. One example, let us suppose we have to write the real number from 2 to 3, set of the real number from 2 to 5. How we will write? So we will say set of all x such that x belongs to real number and it is from x is from between 2 to 5. Between 2 to 5. So in interval form, how we can write? In set builder form, we can write like this, and in interval form, we can write with open bracket 2 to 5, right? So this is semi-open or semi-closed interval, right? Now next we have universal set. What is the universal set? It is again like a superset. It is the set that consists of all the given set, or it is called as the bigger set. The set which consists of all the set in the given context. Means let us suppose here we have set of natural number, set of integer, set of rational number. So if because we know that set of integer, whole number, rational number all belongs to real number or not. So real number will be the universal set for that. If I'm saying just natural number, so what are the possible universal set for the natural number? Because whole number is bigger than that, that means zero also is included. So whole number also may be the universal set, integer also may be the universal set, real number also may be the universal set. Means the set which consists of all the given set, that is called as the universal set. So the set that contain all the set in the given context or in the given questions. The set which consists of the set which consists of all the set, all the set in the given context, in the given context that is called as universal set. Example, what will be the universal set for natural number? What will be the universal set for the natural number? So natural number, for the natural number universal set, we can say integer. We can say integer because integer also included the natural number, right? So integer contain all the natural number also. That means integer is also, or even we can say rational number, sorry, real number, right? Real number, integer, whole number, these all are the universal set. How actually we are representing the universal set? So universal set is, it is denoted by U. It is denoted by universal set is denoted by capital U. Universal set is denoted by capital U, and all the other set are, that is the subset, and its subset by subset by capital A, capital B, capital C, means capital alphabet, right? Like here we are seeing natural number. So natural number will be represented by A, B, C or capital and anything. But integer, if the integer is the universal set for the natural number, so it will be represented by U. So U means universal set that consists of all the other set. That which consists of all the other set, that is called as the universal set. So we have completed these topics for today. Thank you.